Hello and welcome to this presentation on descriptive methods. In this short lecture, we are going to look at methods by which we can summarize qualitative data. Keeping in mind that there are basically two types of data. We have quantitative and qualitative. So quantitative and qualitative. So both of these types of data have their own methods by which they may be appropriately presented either in the form of tables or in the form of graphs and charts. Let's move on to the learning outcomes. So by the end of this lesson, you must be able to summarize categorical data, that is qualitative data, into a frequency distribution table and a 2x2 table. You should be able to interpret the findings from categorical frequency distribution table and a 2x2 table, and also be able to construct and interpret bar charts and pie charts. So qualitative data can easily be described and summarized by these four ways, right? The first one there is a frequency distribution table, a bar graph, a pie chart, and what is known as a 2x2 table, or what is known as cross tabulation or a contingency table. Data can be easily understood when it is summarized, right? That is why we need to summarize data, right? When it's summarized into appropriate tables and displayed graphically by using appropriate methods, then the data becomes easy on the eye. It becomes easy to understand. The meaning is conveyed quite easily. So summary tables and graphs are commonly used to convey these statistical results. Summary tables and graphs can also be used to summarize what is known as a single random variable. That is a situation where you are looking at what is known as univariate, right? Univariate. So whereby you are looking at a single variable, such as, let's say, gender, right, without looking at any other variable. So the variable there is gender, and gender can be, of course, has two categories or three categories depending on how you'd want to display your results. So you may have male, female, or other. Summary tables and graphs can also be used to examine the relationship between two random variables. You may look at gender and alcohol use. You may look at gender and let's say eye color, as we will see in the presentation later on. So in that situation, you are dealing with bivariate, right? So you are looking at two variables and how these variables interact with each other. So moving on. So a few definitions. Frequency refers to the number of times an event or a data point appears in a distribution. So frequency may be determined by counting tally marks for each class or category. The thing to note here is that when you're doing things manually, the old way, without using any statistical package such as, let's say, Excel, where you are not using SPSS or Stata, then you may have to use tally marks in order to keep count, of whatever data points you are dealing with. And you'll see an example of this in the next few slides. So that is frequency. So from frequency, we can get a frequency distribution. So frequency distribution is the representation of data in a table format, right? So the frequency distribution usually would have, at minimum, it will have the frequency, of course, the relative frequency, and what is known as a cumulative frequency, whereby the relative frequency refers to the proportion of the frequency divided by the total. Basically, what we are saying here is with relative frequency, you are looking at the frequency of a specific data point, right, or a specific category of a variable, and how that frequency relates to the entire distribution, right, to the total frequency. So you get a relative frequency, and it's usually expressed either as a decimal or a percentage. And we'll see an example of that in the next few slides. Cumulative frequency is basically the accumulated frequencies of the values of the variable as they increase. And again, this will also make sense when it's presented as an example in the next few slides. This table here is basically what we would call a frequency distribution table, right? So remember I said at minimum it would have the frequency, the relative frequency, the cumulative frequency, right? So here, since we are doing things the old way, manually, so that we get an idea of the principles and the concepts behind the statistical packages that we use these days. So we will use tallies, right? Whereby we will tally everything in order to keep count so that we don't miscount, right? We don't make mistakes. So that's what tallies are basically used for, to ensure you count accurately, you don't make mistakes. Okay, and I'll show you how this is done shortly. Right, the other thing to note, whenever you have a graph, a chart, or a table, you have to have a title and appropriate labels for that chart or that table. That's an important thing to also note. So let's look at this example here. It says assume you have the qualitative data like the following, where F is for female and M is for male, and you have these data points, right? These are individual data points. So this data can be arranged in a table in the frequency distribution by tallying the frequency and counting them. So when we tally, basically what we will do is we look at the data and we just start from right the beginning. We have F here for female, so we'll put a tally mark for female, right? We have M for male, tally mark for male, and we just continue doing that for all the data points, right? We have another F there for female, and then we have another F which makes it 5. When you reach 5, you make your tally to go across, right, this way. So that means that you have a count of 5, right? 1, 2, 3, 4, 5. Okay, so you do this for all the data points. So in the interest of time, I'll just skip to the end. This is basically what would happen. So you have tallied your data points, right, males and females, and then you have your frequencies, right? From the tallies you can get your frequencies. So we have 5, 5, 4. So 5 plus 5 plus 4, that's 14, right? And we have 5, 5, 5, and 1, right? So that's 16. So the total here is 30, right? So there are 30 individuals in this distribution, right? And we have 14 males and 16 females. The relative frequency, remember I said, is the frequency relative to the overall, right? So to get the relative frequency, how we arrived at these 46.7, right, which is, by the way, a percentage. Those are the units, right? So what you do basically is just you take 14, which is the frequency of that category, over the total, right, relative to the total. The total there is 30 times 100. So that would give you 46.7. You do the same for females, and it gives you 56.3%. You add that up, it gives you 100%. Okay. And now for the cumulative frequency, what you do basically is, remember for cumulative frequencies, you have to add cumulatively the previous group to get the next cumulative frequency. What that means is the first cumulative frequency here would be 46.7, right? And then since we have to add the successive relative frequencies in order to get the next one, in order to get the next cumulative frequency, right, this one here, we add the next frequency, relative frequency, right? And if we add this to that, 46 plus 53, it gives us 100%. So that's the cumulative frequency. Once you are familiar with a frequency distribution table, then it becomes quite easy to construct a pie chart and a bar graph, because you are going to use the same information that you'd get from a frequency distribution to display that information now as a chart in the form of a pie chart or a bar graph. Okay, so a pie chart is the presentation of qualitative data in a circle, which is apportioned to different categories of a variable, right? Apportioned to different categories of a variable. If you are dealing with the variable gender, you may apportion it to male, female, and other, okay? As an example, right? So you'd have 3 categories within your pie chart. Assume we have the following data of patients' weight summarized in frequency distribution table below. So instead of using tallies this time, we just skipped that and we moved straight to the frequency, the relative frequency, and the cumulative frequency, right? So we have BMI here, which is the body mass index. The body mass index, remember the units, kgs per meter squared. And so what we have here are basically the categories within that distribution of BMI. So we can have a normal weight, mild, overweight, obese, or severely obese, right? So basically what this table is telling us is we have 200, right? These are 200 individuals in that distribution or in this study, right? So 200, and those with normal weight are 30, mild 10, overweight 40, obese 100, and severely obese 20, right? For a total of 200. And then we get the relative frequencies like we did in the previous example, where we'd just say 30 over 200 times 100 to get the relative frequencies of each of these groups, right? Here we would say 10 over 200 times 100. So to get this as a percentage, right? This is basically what happened here. And to get the cumulative frequency, it's easy. Remember I said we add successive relative frequencies. The first frequency that we have here, the first relative frequency is 15%. The next one we add to the previous one. So we add that plus this 15 plus this 5 to get 20. And then we add this 20 to this 20 to get 40. Right? And then we add this 40 to this 50 and we get 90. We add the 90 to the 10 and we get 100. So that's our cumulative frequency. Okay, so the total, of course, is expected to be 100 since we are dealing with percentages there. Now we can use that information and display it in the form of a pie chart as shown below. And a pie chart can basically be displayed in many ways graphically. So you can use this 3D version, or you can use a simple 2D. You have to label it appropriately, show what each portion represents, and show the relative frequencies of that portion, right? So as you can see here, we have, you can see clearly that we have severe obesity at 10%, normal 15%, and so forth, right? So the way you would come up with these portions, you look at the frequencies on the frequency distribution table, right? So for instance, we know that the circle itself is 360 degrees, right? Remember, we are dealing with angles in the pie chart, right? So it's 360 degrees. That's the entire circle. Okay, so in order to see what angle 15% would subtend, then we would take 15% of 360, right? So that basically means that we would say 15% of 360. So to do that, we say 15 over 100 times 360 degrees, right? So we are basically getting 15% of 360 because that's the portion or the share which is taken by this first category here, normal, right? So to do that, we just say 15% of 360. It comes to 15% of 360 would be 54, right? So 54 degrees. So it means that you can then apportion 54 degrees to this first category, the normal category, right? If you are doing this manually, you can use a protractor, right? There is a device called a protractor, I'm sure you know it, which basically measures angles, right? And it will help you to determine the angle, right? 40 or 54, right? And then you do the same for the subsequent weights as well, right? So for instance, let's take 50%. Okay, so this will be 50%, which is 50 over 100 of 360, right? 50% of 360 is easy, it's 180, right? So 180 degrees, which means the obese patients take half basically of the circle, so half of the circle, right? And that's how we get such a pie chart. You can see that, okay, obesity has taken half, right? The angle is 180 degrees. That's the angle subtended by this category, obesity. A bar chart is basically a better way of graphically presenting qualitative data than a pie chart, especially, right? Especially when you are dealing with many observations, right? Assume we would like to represent graphically the following qualitative data of the proportions of contraceptives used in a particular country, right? So we have all these contraceptions or methods of contraception. So you can see that if we were to present this data as a pie chart, you wouldn't really notice differences. Like for instance, here we have 2%, we have another 2% there, we have 1% here, right? So these differences wouldn't come out, wouldn't be evident, right, when you are using a pie chart, right? In order to avoid that, to make sure that these small differences come out, and to make sure that the graph or the chart is not crowded, we resort to using a bar chart, right? It's much cleaner and more pleasing to the eye if you have many observations. So you can see the number of observations here that we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So a pie chart would be quite messy. We are saying the pie chart can be used for this data. However, it will be too congested and lose meaning. It is therefore advisable to present many qualitative observations as a bar chart or in a bar chart. So in order to construct a bar chart, we basically draw a horizontal line, which is the x-axis, to represent the categories, and then a vertical y-axis to show the scale, right? So the scale in this case would be in percentages or as frequencies. It doesn't matter, right? So on the y-axis, we basically have the counts. So you then construct vertical bars for each category of your variable, right? So in this example, we'll be dealing with contraception. So you are going to construct a bar for each category of the variable contraception, okay? And the height of the bar would represent the frequency count, right? Either the frequency or the percentages, it doesn't matter, okay? And that will be on the y-axis. The space between the bars is important because the space between the bars actually distinguishes a bar chart from what is known as a histogram. This is to imply that there is no continuity of data set, which is the essential meaning of qualitative data. And the width of the bars should be equal to each other, right? So the width of the bars must be equal, and there has to be spaces in between. And then, of course, we are saying use limited numbers of bars for easy comparison. Remember, you are using the bar chart because you want to convince, right, to present data. So you don't want it to be messy, and you want it to be easy to interpret. The sum of the heights across the bars must be equal to the size of the sample, of course, right, which is because you are dealing with frequency counts. That's straightforward. The bars must be equal in width to avoid distorting the or category importance. The order of the bars on the x-axis and the width of the bars does not convey any importance, right? But in most instances, people would choose to arrange them in either descending order or ascending order. Okay, so you can have your bar chart in descending order, right from tallest to shortest, this way, or in ascending order, or indeed, as you'll see in the following example, you can just have them however way you want, randomly, right? So in this example, you can see that the bars are not arranged in either descending or ascending fashion, but that doesn't take away from the discussion of what the bar is trying to convey. You can see very clearly the top 3 or top 4 or even top 5 most commonly used contraceptive methods in this country, right? Cross tabulation, like I said before, is also called a contingency table. You can also call it a two-way table or a 2x2 table. It basically summarizes the joint responses of two categorical variables. Okay, so the table shows the number or percentages of observations that jointly belong to each combination of categories of the two variables that you are looking at. So let's look at an example. So this is a 2x2 table showing relationship between gender and eye color, right? So it's important to note that we have two variables here. One is gender, which has two categories, male, female in this case, and we have another variable which is eye color. And in this case, eye color has two categories, blue eyes and brown eyes. Okay, so and we can see that it's very easy to just at first glance to just see that, okay, we have 22 males with blue eyes, we have 10 males with brown eyes, 29 females with blue eyes, and 21 females with brown eyes. Very easy to interpret. So the other thing you have to note is that you would usually, to complete this, you'd have a total column here and a total row, right? So you'd add up the totals you add up the rows and columns to get your totals there, right? So for instance, the row total here is 32 and the total here is 29 plus 21, that's 50. 22 plus 29, that's 51, right? And 10 plus 21 is 31, right? And you can have the grand total, right? A grand total somewhere there, whereby basically represent the total of the entire table. Cross tabulation summarizes how the frequencies of one categorical variable are associated with the categories of another, right? So association. It can further be displayed graphically, either as a stacked bar chart or a multiple bar chart. Remember that in the previous bar chart, we were only dealing with, this is univariate, we are dealing with one variable which has these 9 categories, okay? But in this case, in the case of a 2x2 table, we are dealing with two variables, and two variables can still be displayed as a bar chart, right? If you know what you are doing, you can still display that as a bar chart to show a relationship, right? For instance, here we can see we have male, that's female, right? That's our variable of gender. And we can see that we have 22 males with blue eyes, 10 males with brown eyes. So the same information that we get on the 2x2 table is still coming out quite nicely in a multiple bar chart. The next type of bar chart is called a stacked bar chart, whereby you stack the categories, right? So basically, you still have this same situation where you have the variable for gender, where you have male, female, we can see that within this category of males, we have those with brown eyes and those with blue eyes. And you can see that the numbers are quite nicely displayed, right? And this graph also is important because it shows you visually the total number of males as well. Okay, so the same goes for females. You can see the proportion with blue eyes and the proportion with brown eyes, quite nicely displayed. Okay, thank you very much for watching. This is all. So in this presentation, we discussed the pie chart, we discussed the bar chart, we discussed the frequency distribution table and how to come up with one. We discussed how to construct a pie chart briefly, how to also how to construct a bar chart. Right. So if you have any questions or comments, please post them below. And in the meantime, please share the video and subscribe. Cheers.